That's totally fine. Okay, thank you so much for coming to my Netflix special. We have Netflix people, they will be recording. We're going to be talking about how to query stream. For those of you who missed that, I was talking about some of the housekeeping items. It's not, it's okay if you will doze off during this talk, it's fine. But I will try to keep you entertained. Now, how many things these days are happening in the world? Everything starts with a tweet. Someone tweeted that something and someone retweeted, and now all of a sudden we have all informational, the buzz around something. And there was a conversation that happened some time ago, maybe last year, in a Twitter between some of the community members. That time I was with the real-time analytics database company, and Robert, he is one of community members, and he's like very active in community. He was asking the questions like, okay, so what does it mean to query stream, like how it would look like, and is it one technology that will give you ultimate answer how to do this, or there would be a set of technologies? And it turns out, like my boss tweeted back, hey, this probably would be good, the conference talk about how to query stream. Or, as a matter of fact, there's a podcast about this and there's a blog post about this. So it is quite interesting subject to explore. Now, for those of you who look in definitive answer, how to query stream, you will not get here. I will give you tools. I will give you technologies. I will try to enable you in order you go to explore. But at the end of the day, choice would be yours, what kind of tool will solve. Because sometimes when you look in something new, maybe you already have something that works for you and it would be perfect. My name is Viktor Gamov. I work at a company called Confluent, regional creators of Apache Kafka. I do all things developer relations there. Had some background in Kafka. Wrote the book about Kafka. If you are interested in Kafka specific things, Google Kafka in Action from Manning. It's a book that I wrote with my colleagues. Yeah, I do all things in internet. If you have we don't have this thing working, but the conveniently placed on every slide, you should get my Twitter, almost every slide. You have my Twitter if you want to tweet about this, but hey, let's go. Now, every talk in the day, we're talking about Kafka, we're talking about any data-related stuff, that any talk that I did in the last, I don't know, 5-6 years, we need to start about something. And usually we start with that people are quite familiar, and usually it's a monolithic application. Application or data system or database, like monolith, something that was undivided, something that is combined storage and query engine, right? In databases, we do have, in traditional sense, in database data storage, we do have storage where your data is placed and your query engine, they tie together, you query, it's easy, you have your application talking to your database, you get the data, it's all, you know, fun, and we were doing this for many years. Now, with the system is growing, when with the different requirements are growing, this monolithic application is not enough, because we need to start moving data around in order to achieve different results. We do have a place where we're capturing all the transactions. In this case, database, we do insert statements. Now we need to perform learn a story, because usually in a transactional, I will be using these two words, like transactional and analytical, in the sense that with transactional we'll care about individual record, like individual sale or individual change on a profile. And when I will be talking about analytical use case, I would need to be careful not to step from here because I will fall. And the light is hitting right in front of my face. So with analytical use case, we would be interested more about the story. How many items we sold for the last year? So does it make sense? So when I will be saying again, transactional, will we care about individual record, maybe key lookup or something like that? When I will be talking about analytical query, it's about aggregates, running averages, and all these type of things. Now, with the world, when we're moving data from one place to another, there's one thing that you can do: extract, do some transformation of the data so it will be available for consumption on the other side, and load this back into another system. Another approach for data integration is actually capturing the changes that happen on database side of things when you're using your transactional data store or your operational data store. Update a record, we can generate another event that will be representing how data is changing without touching the initial source. And with the world of the mobile applications, those approaches are not gonna cut because of the sheer size of the data and how data arrives, speed, and all these kind of things. So the mobile explosion of the mobile and explosion of APIs, explosion of the things when the people do on their devices, it changed the way how data needs to be treated. And for a very long time, data integration and data pipelines started becoming the way how the multiple systems start integrating. So you might have one system that will be writing data to operational data store, and would be totally another system that would be reading from this data source, slightly transformed with the patterns like that kind of, you have a different schemas for read and writes start appearing, like UCRS type of things. You start building microservices, and you're representing your data or your system not in the form of database or like providing access to this database, but you're presenting this system in the form of API, and API also can be changing and can evolve. And the one thing is stays kind of like in the world of this, like pipes and pipelines and things that move in between the system, between microservices. There are different ways how we can integrate those microservices. That could be request response, that could be some sort of like a RPC style approach or messaging style approach. And one of the pattern emerged. Hopefully you can relate to this. I don't know what's the experience in the group about Kafka, is to place all these things that happen in the world in this structure called log. How many of you actually using Kafka or log-based data systems, maybe Pulsar, maybe Kinesis in the room? Okay, so I'm curious what else people might use if they're not using Kafka today. Which one? Rabbit. Okay, so Rabbit is another messaging system, but it's not the log-based structure. So log, what's the difference between systems like Rabbit and systems like Kafka, Pulsar, and log-based systems? So with the Rabbit, you have durability of your data is kind of sort of, afterthought. The messaging system is more designed to be for like high throughput systems, where the log-based system, they essentially store the data in a way that can be accessed, but in sequential format. So that's the only difference that people have. So that's why there is always misconception in terms of like, what's the difference between Kafka and Rabbit. Kafka provides distributed transactional log with immutable messages. With messages systems, you can have some sort of durability, but it's not the main point. Now, since everything, events, change data capture things, ETL pipelines, microservice communications go through the Kafka. So that's why this is where the question comes: how to query this log? Because log-based structure, it's immutable. It is optimized, so you can writes happens very fast because there's no random writes. It's always writing back to this log. Very quickly, how you can grasp what the log versus or like stream versus table with this. How many of you play chess? Few people. All right, so in the chess, you can just win it, or you can go this like professionally, because you can play, and after that you can analyze how well you played. And in order to analyze how well you played, you're capturing every step, yours and your counterpart. So we have this list of the moves that you have in chess. That's your stream. But in a given moment of time, if you will be, for some reasons your board get destroyed, or someone just use their hands and just throw all these figures out, having this log, you will be able to restore in the state of this game in a given moment of time. So log is quite powerful, but here's one thing that you need in order to, get this state out of this log, you need to replay this from the very beginning. So that's why the querying this log is quite challenged. You need to find a way how this stream can be materialized. No pun intended. You will understand why, because there would be a lot of talks with the materialization of the stream. And that's basically the premise of the talk. People asking, okay, so we have everything in Kafka. Like LinkedIn showed how they build successful social network based on the Kafka. All events that happened in LinkedIn go into Kafka. Now, how you can query, how you can get information about, oh, okay, who viewed my profile for the last, I don't know, for the last 2 days. So in this case, it's your analytical queries, because we're trying to get the story out of this log. Now, if you're interested in particular, like a transaction, it's also not very straightforward how you can query this log for particular key. Yes, many of you know that Kafka messages will have a key and value, but you cannot just go there and say, hey, give me something by key. So also not very suitable for this like transactional use cases. So now let's go into this. That's exactly what I just explained. It's kind of like a transactional versus analytical. Transactional, I will be using this as a key lookup type of style. Analytical, if we're trying to do any sort of aggregation and stuff like that. Now, so usual suspects for this type of conversation. I'm gonna talk about the Kafka Connect, Kafka streams, different flavors of new emerging technology called streaming SQL or streaming databases. We're going to talk about cloud data warehouse, data lakes, and real-time analytical databases that also new in emerging, relatively new, emerging form of this analytical database. Okay, cool. Any other kind of like suggestions or the questions? Maybe I missed something in terms of like maybe people using something else. People can say, what about Redis? No? Key value or like distributed cache or something like that. We're gonna talk about the first suspect, Kafka Connect. Anyone using Kafka Connect? Anyone heard about Kafka Connect? Something happens for the first time for many of you. Okay, you're lucky. So Kafka, Apache Kafka, it is an open source project that is under umbrella of Apache Software Foundation. But in many use cases where I'm talking about Kafka, for many people, Kafka means Kafka broker. So the system that would be, we will producing messages to and consuming messages from. But also, Kafka itself, it's not only the broker. Kafka is a whole streaming platform because it has all multiple components that is related to things, how you can ingest data and how you can extract data from the Kafka. And Kafka Connect is a framework that integrates with Kafka. It allows you to build integrations with your external systems. Remember when I was talking about this ETL versus CDC approach, how people will write the jobs to extract the data from one database, do some sort of transformation and load it some other place. So the Kafka Connect gives the part with extract and load. So there's two types of connectors in Kafka Connect. One connector is the source connector that will be listening your source system and pushing this data into Kafka. And there's a sync connector that will be listening stuff from Kafka and pushing to the system. So now, how this related to our conversation about the querying the stream. So maybe there's some tools that you already know how to query. Say you have a relational database, you have Redis that will be suitable for your transactional use case. You need to do like a key lookup. So in this case, using Kafka Connect, we can just simply listen the stream and materialize the stream in some storage that already you know how to query. Since Kafka provides key value store, very good candidate would be some sort of like a distributed cache or key value store. Or if you want to perform more in terms of queries, you want to not only do key lookups, you want to do the story, maybe you want to do some projections. Take the stuff from Kafka, push it through the Kafka Connect, and now you have your data in your relational database. And this pattern can be used if in this particular case, data sync can be anything else. It can be database, it can be distributed cache, it can be data lake, it can be cloud warehouse. It is quite powerful technology. However, there's some drawbacks with this. So when I said that it's suitable for smaller data, it doesn't suitable for bigger data. I don't mean that it is not capable of handling like millions of records. It definitely can, and this is the whole streaming platform built on top of the Connect. Here is more about your ergonomics, like how comfortable you will be with querying, say, thousands of messages per second, and you want to get the immediate response, and you need to understand like how your data, based on the changing data, what you have in your database. And in this case, we're trying to adopt existing tools, and they may not be very suitable for real time. Historically, it's a transactional, oriented for transactional because key value nature of the Kafka. Extra infrastructure. So you need to also maintain the cluster of connectors in order to get this data from Kafka. There's a limited transformation capability. So Kafka Connect provides the way how you can quickly transform your messages. Say there's the thing called SMT, single message transformation. You will be able to say do small things, convert data like timestamps into different ISO format and things like that. But it's not. There's no like stream processing. You will not be able to do any type of the analytical queries. So that's up to you. Now, another component of Apache Kafka as a streaming platform is Kafka Streams. Anyone using Kafka Streams these days? All right. Why are you not using Kafka Streams these days? Okay, so the answer, I will show you what Kafka Streams in a second, but essentially, again, 3 letters, ETL, extract and load, you have a Kafka Connect, and now for transformation, you need to have something that's quite powerful. And this is where the Kafka Streams comes into play. Kafka Streams is a library. So you have your Java application, you drop a few jars there, and now your application is stream processing application. It's quite powerful. With stateless stream processing, you can do simple filtering, you can do simple kind of like a mapping operation, transformation, but also, that's what like in a transactional sense. But also you will be able to perform more or less analytical style transformation. You'd be stateful. You will be able to do the joins. You will be able to do aggregations and all interesting things. It is one of the powers of Kafka Streams is the very intimate integration with Apache Kafka. Also, it turns out it's one of the weaknesses of the system as well, because tight integration with Apache Kafka. And when I say Kafka Streams would be, you know, the good the candidate for querying the stream, there's an abstraction called K-table. Remember when we were talking about the chess, you have this log that represents your the set of moves, and your figures on the chessboard right now are represented as a state of the game, also known as a table. Basically, it's a state for particular object. We can quickly look up based on the key. It's essentially hash map, but also backed by Apache Kafka in case of failures and stuff like that. So since it's intimately connected to Apache Kafka, depends on the topology of Apache Kafka. So these, like a key table and key streams, they are key value type of pairs. And you can read this through interactive queries. So let me Let me quickly show if this, if it makes sense what I'm talking about. Still running, it's still running, okay. Now, this is the example that it's just simple Java application that has this topology. So it's a word count. Anyone wrote the word count in data systems? Anyone? It's basically hello world for how you learning from new data system. You write the hello world in Hadoop, you write hello world in Spark, you write hello world in Kafka Streams, in Flink and stuff like that. So, this API provides you to do multiple interesting things. So, for example, let's start with this this particular step. This is where we take a stream, that Kafka topic, and we can do some sort of like transformation along the way. So, in this particular case, we're performing split to generate another stream of words. We take the sentence, we slice and dice it by words, and you put them in the lowercase because we don't care about the case. We care about number of words. So that's how it reads from Kafka topic, and your application in this particular case will becoming the thing that will be querying your stream. So in this case, you can already see what would be drawback. So if you have like a new use case, you need to change application logic in order to query the data. If I'm going into, we talk about transactional approach per record. And with the analytical approach, there is an API that allows you to perform aggregation, joins, and all the things that you can develop this like story about your data. Here's the problem with this. It's always query by key. You need to know the key in order to get the result. So there's no way you can say, hey, I want to find the way, what, I don't know, who was the director of top 5 Oscar movie for the last 10 years. So it would be not super easy to do in the Kafka streams. Now, and for each and every use case that you're building, you need to build your own topology, you need to build the application needs to be deployed, you need to make sure the application is running. If something will fail, it needs to be restarted, so far and so on. And in order to deal with this, and in order to capture this thing, so this is kind of like a use case where I'm bringing some of the analytical functionality in this Kafka stream. So in this particular case, I can perform count, and the result also can be materialized. So it will be materialized as the word count state store that will be represented. Key would be word, and the value would be the number of words that happened there. And in order for me to query this information or like make my application to be available for everyone who wants to use this API, we need to do something like this. Kafka Streams it does come with certain like data building blocks, but it doesn't come with any type of like RPC style in order to expose this thing through some sort of API. You need to implement this yourself as a developer. So in this particular case, we do have this concept of the interactive queries, which is essentially take this state store that we just like populated. Remember, we have a stream of chess moves, and on this particular moment of time, we have a state of our game in the board. Same thing is here. Our state store will give us state of this particular game in given moment of time. And now I'm just wrapping this state store with some sort of like a REST API. In this case, it's a small, tiny Java Spark framework. Don't be confused with this like Apache Spark framework. And if I have Word, let me quickly show you. So if I'll run this producer, should have some data there, still running. And if I will run my application, so it will have two components: backend, where we're going to be querying our stream for words, and the front end. So in this particular case, it would be something like this: like how many times word lethal appears in this. It's a stream of movie titles. Lethal weapon, it's one of the things, or just like, I don't know, some love movies. Yep, you have. That's better. We have a more love here. But if you don't know key, you will not be able to discover. You need to know the key. So it is quite powerful, embeddable in your application. Your application immediately will get the opportunity to, get data from the Kafka topic, not in the form of like messages and things like that. You will have your domain object that you will be able to query and expose in your application, but it's too much things to do in order to implement this simple use case to query this stream again. Yeah, that's kind of like the same thing I just discussed. We have the materialized store. We do have a key table that will represent the data that comes from Kafka topic and so far and so on. Now, that's something that you can do today out of the box without bringing anything else. If you're using Kafka, you have a Kafka Connect. There's tons of connectors that allows you to connect to your existing data stores. And your Postgres will be thingy that you will be querying. Now, this is very interesting. So for the last I don't know, like 3-4 years, the world of the streaming things just exploded. There's tons of new technology every day, and today I'm going to talk about few. But maybe I need to, next time I need to update this list, my personal favorite technologies that follow this new concept of streaming SQL. So, and the motivation is also very clear, right? In the previous example, we use Kafka Connect to dump your data in storage that supports querying this SQL. Why we need to have intermediate, why we cannot have something that can run SQL on top of our Kafka data without having the Kafka Connect or at least not exposing this to users. So, and this is the 1, 2, 3, 4 technologies that I want to quickly talk. Definitely there's more. There's some proprietary technologies, some open source, and those are kind of like streaming databases, whatever it means. And anyone using any of those or at least heard about this? All right, something new every day. Okay, so let's talk about the Flink. Anyone using Flink? I was expecting, when I was showing this slide, I was expecting a question like, Viktor, where's the Flink? Is the Flink also good example of SQL query? I just saw one person using Flink. I cannot believe that, 2 people, okay. Apache Flink, it is a stream processing framework, general purpose, distributed, highly scalable, highly available, what have you. And initial implementation and initial use cases were based off the conception that people were writing either Java or Scala data streams programs. Flink, you have a cluster of application of nodes. You write your Flink data stream application, and you deploy this in a Flink cluster, and it runs it for you. And it doesn't have tight connection to Kafka, even though there's a connector for Kafka. It doesn't have tight connection to Pulsar, doesn't have tight connection to others. But there are tons of connectors that allow to Flink to get data from something, do something with this data, and dump without involving Kafka. So that's the step forward comparing to the thing that we have with Kafka streams, because there's like very, very tight connection to Kafka. In some cases it's okay, in some cases it's not. Flink also come up with Flink developers, they come up with this idea. So what about we give people ability to express these data stream jobs, not only in the format of Java or Scala. Any Scala developers here, no? Thank God. It's like less and less people who saying, oh, yeah, I'm Scala. Kotlin? I like this better. Like, I like when they have more Kotlin developers than Scala developers. So what about we give you ability to express your stream processing job in SQL? So that's what this the Flink SQL is. And when the people see in SQL, they always have this feeling that SQL is something from databases, is Flink database. I'm not going to answer this question today, but my friend David Anderson has an awesome video. You can take the screenshot of this, and it explains, is Flink a database, or Flink SQL is a database or whatnot. Spoiler alert, it's not. But it's a good video in terms of understanding that not all SQLs make equal. So that also allows us to jump into this in this conversation. Now, Materialized. Anyone using Materialized? It's a pretty cool tool. It's also open source. If you are geeking around with the data, I highly recommend you to play around with this a bit. Written in Rust. You know, internet points we'll get for using Rust. It was researched, the overall like a concept of this data flow was researched in Microsoft, and after that people left the Microsoft, they started building this product called Materialized. Now, what makes a database? For database, you need to have a storage and you need to have a query engine. So that's why I cannot call, with all due respect, I cannot call Kafka as a database. Kafka is a storage. Kafka is a streaming platform, but Kafka is not database because it lacks of query engine. So the technologies like streaming SQLs, they usually combine storage in some form and the query engine. The streaming sources usually is just what it is. It's a streaming source for those systems. It can be use Kafka as a streaming source, or can use Postgres as your kind of like a batch source. It's materialized and maintained views is a general concept that you build this the view on top of your data, and it will be stored and cached, and you will be able to query it. So this is much more suitable for use cases where you need to implement multiple use cases on top of your streaming data, but also have ability to cache it somewhere. Okay. As I said, the views are persistent, they're queryable. And another interesting observation is that the Postgres as a concept is also becoming a international language of communication of data systems. Majority of the systems that I was exploring, they have some sort of wire-based compatibility protocol. It doesn't mean that you will be able to perform or like move your workloads from your Postgres into Materialized, but you still will be able to use your tools in order to write the query or explore the data in your Materialized database, so which is also pretty cool. Remember again, transactional versus analytical. This is more analytical solution. You're writing these queries where you don't know keys. It's not oriented for individual records. It is for building real-time analytical dashboards or stuff like that. Delta Stream, cloud-based native SQL data stream. The Delta Stream actually uses Flink. They implemented this solution, a cloud-based streaming SQL based on Apache Flink. All usual suspects. It also has a storage. Also has a concept of materialized use, the accent with Delta Stream, integration with like technologies like a data lake at cloud. They have a capability that they can run their data planes in your data center instead of you bring your data to them. You have already data in your systems. They only provide you with control plane that allows you to perform these queries and manage your fleet of data planes. Rising Wave. Any users? This is very interesting. So, like, if for some reasons, again, it's a very loaded statement I will make right now, and I will be recorded. But if for some reasons, I know it's weird to say this in a Java conference, if you don't like JVM and you're not gonna put up more with the Flink stuff because it's a JVM based, this is probably what would be a very good candidate for you to explore. So Rising Wave is a system that has a lot of inspiration in Flink. because the things what it does, more like a Flink SQL. But because the interface that you're writing with the Rising Wave looks to Flink SQL more. Instead of like going slide, let me quickly show you how they would look like if I would write this in Flink. So same use case for word count. If I would take this into Flink SQL, for example, this is how this would look like. And it is look like your, let me do this bigger. I feel like, yeah. There's a couple interesting things. You look at this one, it feels comfortable because you already done many things with SQL before. So this is how we're gonna be parsing these words that coming into the Kafka pipe, they explode, and we have a split that will separate these sentences. And we're getting this as a result into something that we can query, word and count. So that's what the Flink does. And if we're gonna look into Rising Wave, and so Rising Wave would look something like this. Very similar, so in this case, they also will have a materialized view that would be constantly updated. Slightly different syntax for splitting, but once you know what you want to do, you can figure out that, okay, so what kind of function they use for splitting things. Another thing that a Rising Wave has that very similar that Flink has is to have sinks and sources, connectors. So in this particular case, how we can get the messages from Kafka, this is how we connect to Kafka. Also, we're using SQL. Again, in Flink, it creates your stream processing topology. In Rising Wave, only thing that would be will have a state is this materialized view, but this is also those connectors will behave the same way how they behave in Flink. Now, so essentially, it has a storage. There's no, I guess, intimate connection with Kafka. Flink doesn't have storage. Rising Wave has storage. But Flink has a storage, but Flink has a storage for different purposes. So some of the intermediate computation that happens on Flink, they can be preserved, but this is on for the purpose of Flink to be fault tolerant and stuff like that. Now, KSQLDB. Anyone who was using KSQLDB in the past? Good. So KSQLDB, it was a very cool experiment while it lasted. What if we're going to use this concept of Kafka streams that I explained you, right, with the writing the topologies, but instead we also take the SQL and we turn it into Kafka stream topology. So will it make Kafka streams as kind of like your database of choice? I don't know, maybe. But KSQL, KSQLDB does exactly that. So you do have SQL, which is another kind of experimental thing with Kafka streams and the KSQLDB. SQL was not standard. It was used like a subset of SQL, has a little bit customized SQL, so you can have like a create stream, create table type of thing that was not available in SQL at the time. Some cool things were there with the pull and push queries. Pull query, this is something that when you write select star from something and you get the massive number of rows back. And the push query is something that you can say select something and wait until the new changes will arrive. So that was a very cool concept if you were building something kind of like a reactive style application, you expecting the data would be pushed. And that was pretty cool. However, since it was based on the Kafka streams, intimate relationship with Kafka, not permitted this technology to be kind of like a super wide adopted. It's still a very good example of things how you can query your stream, but KSQLDB doesn't have its own storage. It uses Kafka as a storage. So in this case, you can say that Kafka plus KSQLDB will make this a streaming database, but again, it depends how far you want to stretch it. All right, so a few more notable mentions. Cloud data warehouses. This is exactly what it says. You have your the Biquities, Redshift. Have you ever anyone used Redshift, Amazon Redshift? Why logo is blue if it's Redshift? Like, can you imagine like the and again the Snowflake, Synapse. Can you imagine there's a meeting in Amazon happening when they're discussing what kind of colors this logo needs to be, and there were like 25 people in the room. They were very important. They were discussing like what kind of color. We can use different like gradients of the color. Like why blue? Why not yellow? Why not red? So anyway, so the cloud data warehouses. That's your data warehouse in the cloud. It is can be ingested from the batch. Can be ingested from the stream. Usually, if it's like specific to a particular cloud, it has a tight integration with underlying systems like the Redshift, the Kinesis, MSK, or BigQuery, and some other technologies that Google has in their data warehouse. And since it's a historically thing that was situated around batch, you can ingest stream data, right? So you're writing data into these data warehouses, and this is where you have your query capabilities. Very similar to the things that were already discussed. Data lake. So basically, we do have sources, different sources. We have files, we do have databases, we do have the Kafka streams, and after that, in the data lake. And now we have a data lake, so unstructured, and we'll figure out. This is example of this. We were talking about ETL. You kind of extract, you prepare the data to transform because you have a schema that you will be ingesting in your system. This is ELT. So in this particular case, you kind of, when you ingest it here, you figure out only when you will be reading. Based on when you will reading, you will be enforced schema. It's kind of schema on read type of situation. Yes, you can use this to query stream as well. Started as the HDFS. More and more people use the S3 as a storage. This is the difference between like we have a ETL versus ELT when we have get the data from somewhere, load it, and after that we'll figure out when we need to query this data. Keep an eye in this field because the Iceberg is another Apache open source project. This is the format of how this data can be expressed, or like how this data can be structured and things like that. So the table format is very important. Again, not super pleasant thing to deal with. Last but not least, real-time analytical database. I used to work at a company that built the managed service based on the super cool database called Apache Pinot. It is a real-time OLAP database. Super cool database. I cannot even I'm not working in this company anymore. I still like to talk about this because I think it's a super cool technology. I think, in my humble opinion, it's still ultimate solution for querying your streaming data. It was supposed to be kind of like, because it was the last slide of this presentation, and I used to work in this field. But I truly believe this because. This system is a database, so it has its own storage. It has its own capability for storing data. It has connection to batch and streaming sources. It has a native support for Apache Kafka. You can query data from Kafka and immediately available this for running aggregation or like any type of analytical query. It has indexes. It has all sorts of things, geospatial indexes, vector indexes. It's super cool. Intimate integration with Kafka, Pulsar, with Kinesis. You can have all the streaming sources dumped into the Pinot, and you will be able to perform all sorts of analytical queries. It's not transactional though; it's an analytical system. Blah blah blah. Super cool. There's only type of like a pool queries. Even though we're querying the streaming data, we need to pull this data from the Pinot by the end of the day. Now, last few slides. No solutions, only trade-offs. Usually, when I was working in consultancy, I used to say, it depends. Now, I just adopted this phrase. Now, when you're choosing a solution, there's maybe you're already using something that works for you, and it solves your use cases. Remember use case with the Kafka streams. You already have your database in SQL databases. Like, why not just have a connector that ships the data into your database and you're good to go? Good thing is that you already have a solution that solves your problem, right? Next thing is usually my Western European and Eastern European friends like to talk about performance, like how fast, what's your like 99 percentile of the queries, what's the tail latency, all this type of jazz. This is something that some people can enjoy talking about, and it's a good topic to talk about. There's a majority of the systems that I bring, they have some sort of like the reading materials explaining the performance aspect, like how to scale things. For example, Pinot has separation between storage and query. You can scale those things independently, depends on your use case. If you have more data, you need to maybe scale the storage. Same thing with the Kafka streams. What's the latency would be on performing some sort of aggregation. That's an important topic. Very, 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 very overlooked aspect. You don't want to use the tool, probably. I don't personally use the tools if the people who created these assholes. You know, why I would? Like, if I have a question, I need to go in back and they will be explaining this stuff to me. No, so that's why I hate Scala. Now you have it. Thank you so much for staying for my tech talk. It was super difficult to start in the very beginning because you have at least like a PhD or at least like a master degree in math, because otherwise you cannot talk to the speaker about their like type categories, monads, and all this type of bullshit. Kafka community is great. Apache Pinot community is great. Flink community is awesome. The people who help you to explain different things, you can find them in Stack Overflow, you can find them in Discord, you can find them in Slack. That's a very big point, where you can find the answers to your questions. My first programming language, I pick up this not because it was super cool. I pick up the Pascal, not because it was cool, but because there was someone in my neighborhood who can explain me Pascal stuff. I didn't have any C++ developer in my neighborhood, but I had a Pascal, so that's how I picked up this. So community is the big part of selecting the right choice. But by the end of the day, there is a different pieces of application code that talks to Kafka, and this is your area exploration. And there will be monsters, but I hope this presentation at least give you an idea where to start digging. With this, my name is Viktor Gamov, and as always, have a nice day.